Good afternoon, everyone, and thanks for making the time to join our webinar today. My name is Damien Fadden, and I'm the chair of the Society of Actuaries Healthcare Committee, and it's my pleasure to introduce our topic and speaker today. Before doing so, some housekeeping. The full webinar, including the Q&A, is being recorded and will be posted to both ActiveView and YouTube afterwards. We hope to have plenty of time for a lively discussion at the end of Ivor's presentation. You can submit questions through the Q&A portal at the bottom of your screen, giving your name or anonymously if you prefer. Or if you click the raise hands button, we can unmute you to ask your question the old-fashioned way, which I would encourage. As you know, there's no longer a requirement for verifiable CPD for the Society's CPD scheme. But if you need that for any other purpose, there will be a record of your attendance at the event if you've registered with your full name. And I'm pleased to say that Laura O'Philbin, who is the head of research with the Alzheimer Society of Ireland, has joined our webinar today. Thanks for making the time, Laura, and please feel free and welcome to engage with any comments or questions in the Q&A section. The webinar today is a summary of the paper Prospects for Alzheimer's Disease Medicines produced by Ivor O'Shea. You can access and read the paper via the Society's events page. And for those who haven't read it as yet, I would recommend you do. It's a very interesting and very digestible paper. Even though Alzheimer's disease is one of the leading causes of death in developed countries, there have been no medicines proven to successfully treat the disease or even to slow down its progression. There have been exciting developments in the space very recently, however, with 2 new potential medicines demonstrating some effectiveness in treating the disease. Ivor's paper gives the background on Alzheimer's itself, explains why it has been so difficult to develop effective medicines for its treatment. It then goes on to give some context on the benefits and the risks associated with those 2 new medicines and the impact they may have on future longevity progression and the utilisation of residential care facilities. And finally, the paper comments on the prospects of additional new medicines emerging. Turning to Ivor himself, Ivor spent just under 25 years building a very successful career in the life assurance and health insurance industries before becoming a full-time investor focused on the biotech sector. He has invested in over 600 listed biotech companies, giving him significant practical experience in assessing the effectiveness and commercial prospects of potential new medicines and a unique perspective in considering the actuarial consequences of such developments. Ivor has been an active participant in society affairs as a past council member and treasurer, and is a long-standing member of the Society's Healthcare Committee. He's been a prolific contributor to society events, not least in our recent pandemic experience when he presented a number of hugely insightful updates on the progression of COVID-19 medicines. We're very grateful to him for the effort and time he has committed to producing a very interesting and substantial paper and for his preparation for today's presentation. So I'll hand over now to Ivor to take you through his presentation with a reminder that you can submit questions through the Q&A portal throughout the presentation or by raising your hand at the end. So over to you, Ivor.
Good afternoon, everyone, and thanks for the very kind introduction there, Damien. So before I get into my presentation itself, I would like to just deal with 2 housekeeping matters. So firstly, there is a disclaimer here. I'll pause for a couple of seconds. As you probably can see here, I never avoid taking any opportunity to point out that I don't work anymore. So hopefully you've all managed to read that. The next one here is the relevant competency framework wheel for this presentation. Again, I'll pause here for a couple of seconds for people to have a look at that. And now I'll move into the presentation itself proper. Alluding to some of the same comments that Damien has made there, that this presentation is a summary of my own sort of written paper on this topic, and that's available to download on the Society's website. Based on my own career in investing in sort of biotech, I've always been fascinated by the area of Alzheimer's disease, such a critical disease, but on the other hand, no real available treatments for it. I'm trying to understand how that could be and how that might change in the future. So in terms of the agenda for today, there's a number of questions here that I would like to answer or to give you a view on. So firstly, to define Alzheimer's disease. Secondly, to talk about the current medicines that do treat some of the actual symptoms, but not the disease itself. To talk through the considerable difficulties there are in practice in developing new medicines for Alzheimer's disease. And then, as Damien has actually alluded to, there have been two important breakthroughs in recent sort of months. And just to talk through those new medicines, and also critically, the potential impacts of these two medicines. And then last but not least is to talk about the prospects for further new medicines in the areas of Alzheimer's disease. So to talk about firstly defining Alzheimer's disease, I think rather than talk about current affairs, I think it's important to perhaps look at through the lens of sort of deep history. So if we look at the history of Alzheimer's disease, the first real written records we have of it come from the ancient Egyptians, records that it is generally believed go back to 2500 to 3000 BC, do describe Alzheimer's disease in various medical manuals that the Egyptians produced. If you look through some of the texts, they talk about the patient's mind being submerged, as if they're constantly thinking about other sort of matters and not what's in front of them. Overall, they are a relevant description of Alzheimer's disease. Now, the ancient Egyptians' view was that dementia and Alzheimer's disease were in fact just a natural but sad part of the aging process. They did not really regard it as a specific sort of illness. Now, the Egyptians were not alone in sort of thinking that. That was the general view across the entire world. There were some dissenting voices, notably the former Roman Empire head of state Cicero, who did argue in writing that if it was a natural part of the aging process, why didn't everybody get sort of dementia? But generally speaking, it was viewed as just, as I said, part of the aging process. Now, that view then prevails up until the 19th century. And at that point, things do start to change. It is regarded as an actual disease. Cicero's point that not everyone actually gets it is very, very striking. But the general medical consensus is that Alzheimer's disease is in reality, it's a vascular issue. It's an issue of perhaps repeated strokes in the actual brain. And that's what people sort of thought about it. That then holds right up until the start of the 20th century. And it's worth talking about this for a couple of seconds. So in 1901, we have Dr. Alois Alzheimer, who's a neurologist and a pathologist, and he's operating in an asylum in Munich, Germany. And a new patient comes into the asylum who is exhibiting very strong signs of dementia, and also some side effects that might be referred to as agitation, which I'll talk about later. That doesn't seem very remarkable in of itself, except for one striking fact. The patient is actually aged 51, and that's totally out of line with the prevailing thinking on sort of dementia. So he decides to follow this case. This patient then sadly passes away just 6 weeks short of her 56th birthday due to complications arising from her dementia. There is an autopsy carried out. The autopsy reveals some very specific pathology going on. And Dr. Alzheimer then realizes he's dealing with, in fact, a very distinct disease. Now, that might be a curiosity at that point in time, but there's a very important development that is both good and bad. The good part is Dr. Alzheimer's mentor, Dr. Kraepelin, is a very important figure in the area of psychiatry. He publishes a very influential manual of psychiatric diseases. And in one of his updates, he actually includes this new disease discovered by Dr. Alzheimer. And as we now know, he bestowed the title Alzheimer's disease on this new illness. And that then led to worldwide recognition of this as a new sort of feature. However, the actual downside was that Dr. Kraepelin categorized Alzheimer's disease as more or less a rare oddity, that it was something that struck people perhaps in their 50s or early 60s, and was actually a distinct form of the general form of dementia, which struck people more from age 65 plus. So he didn't make a link between what we understand as Alzheimer's disease today and the cases that Dr. Alzheimer had actually sort of come across. And in that view, again, mistakenly prevails right up into the 1970s. Some UK doctors start to point out there's some evidence that Alzheimer's disease seems far more prevalent than it generally thought, but doesn't get a huge amount of attention. But it does go up until 1976, where a US specialist, Dr. Katzman, He writes a hugely influential editorial. He identifies Alzheimer's as the dominant form of sort of dementia, that the previous view of it being vascular is completely wrong. He estimates that Alzheimer's disease is responsible indirectly for being the 4th to 6th biggest killer in the actual US, and that the medical profession and the pharmaceutical industry needed to turn their attention to this dramatic sort of new sort of illness. And from 1976 then to today, the pharmaceutical industry and scientists have been seeking to develop sort of new medicines here. And the position we find ourselves in today, that in most developed countries, Alzheimer's disease is a leading cause of death. And in fact, in the UK, dementia is the leading cause of sort of death. And Alzheimer's disease makes up 60 to 80% of those sort of cases. And there are no effective medicines. But a key point from this whole history, and I think it's very, very important, is if you ask the general question, how come we can't treat Alzheimer's disease? Well, one of the key points is it's only about 40 years ago that we properly understood what it actually is. That's totally at variance with illnesses like cancer and heart disease that were actually familiar to the Egyptians as far back as 3000 sort of BC. Now, moving on to Alzheimer's disease itself, there are 4 key hallmarks of this disease, and I will talk about these throughout the presentation, so it's important that we discuss them. Firstly is amyloid plaques. So amyloid is a benign brain protein. Now, what happens in Alzheimer's disease is this protein starts to become corrupted. And in 2 stages, the first one is an intermediate stage where it's actually soluble and it just moves around the actual brain. And then laterally, the soluble form starts to clump together and it turns into plaques, which are very visible on autopsies and in more recent years, brain scans. What you then have as well is the death of sort of neurons. So neurons are at the core of the brain's cognitive ability. And what happens in Alzheimer's disease, as disease progresses, these neurons functioning degrade, they lose connections to each other, and eventually they actually die. And you can draw a straight line between the death of these neurons and the decline in patients' cognitive ability. The third point here is what's known as tau tangles. So tau is another benign brain protein, but importantly, it's only found inside neurons, whereas amyloid is found outside of neurons. Again, in Alzheimer's disease, this protein corrupts and eventually it turns into clumps that have been referred to as sort of tangles. And these again are found in autopsies. And last but not least, another very sad feature of the disease is as the disease progresses and neurons die, the brain actually shrinks or atrophies. And this is very evident in the more advanced cases. And if an autopsy is done, you will see very, very sadly, the brain is distinctly shrunk from its normal size. And for reference, Dr. Alzheimer, in his original autopsies, discovered amyloid plaques. He noted the issue of neuronal death. He uncovered tau tangles, and he also noted the atrophy in the actual brain. So he had a very distinct idea about what was going on. Now, Alzheimer's disease has a number of stages, and again, I'll be referring to these throughout the presentation. So the first one is preclinical, and perhaps this is the most surprising one. So as the title suggests, at this stage, the patient will feel absolutely no sort of symptoms. No one, no friend or family member would see anything sort of going wrong. Now, this sadly starts up to about 2 decades before symptoms actually sort of arise. And the reason this is known, if you look at patients in this stage, you will see amyloid plaques forming inside their actual brain. The causes as to why this actually starts off are just not sort of known. Then we come to perhaps the first public stage of the actual illness, which is prodromal, sometimes referred to as mild cognitive impairment, or MCI. This is where there are minor symptoms. The patient might forget some words from sort of meetings, sort of things like that, but they can still, for instance, hold down a cognitively demanding job. Now, these symptoms, because they're mild, they can be confused with other illnesses such as depression, anxiety, stress. And while doctors might be a bit suspicious about what's going on, they may defer diagnosis until the symptoms are more clear-cut. And this then usually happens at the mild stage. So here the symptoms are clear-cut. There will be frequent losses of memory and other similar behaviors. And this is where most diagnoses are made. Now, patients probably could not hold down a cognitively demanding job at this stage, but they can still handle the activities of daily life and they do not require assistance. This then escalates to what's referred to as the moderate stage. And here, sadly, the symptoms do become quite serious. I quote the example here. A patient may not recognize members of their own family. And unfortunately, patients do need support with the activities of daily life, and they do require constant oversight for their own protection. And then last but not least, there is the severe stage, certainly the most aptly named one. Here, the loss of cognitive ability is almost total. The patients can no longer talk, and they importantly also start to lose control of muscle function. This includes issues like swallowing, for instance. Patients are usually bedridden and they require total support on a 24-hour basis. Death then frequently arises from pneumonia and falls, pneumonia often arising from food being swallowed that goes down the wrong way, lodges in the actual lungs, becomes infected, and this leads to pneumonia. It also leads to one of the major problems in counting the number of deaths from Alzheimer's, because you have to make decisions about how many pneumonia deaths and fall deaths actually belong to Alzheimer's. Importantly, given the audience here today, I thought maybe it's useful to show some demographic figures. And so the first one up here shows the incidence rates of, the diagnosis rates of Alzheimer's disease. If you look at different tables, they will give different data, but this is the one I've decided to kind of go with. You can see here from age 65 to age 75, very low frequency, certainly starts to escalate in the 75 plus category. And come age 85 plus, you could argue what that figure there is saying is that once every 3 years, you have a 1 in 5 chance of contracting Alzheimer's or being diagnosed with Alzheimer's disease. These figures are combined for men and women. The figures for women only would be somewhat higher, but not as high as some people might sort of think. Typically, lifespan is 8 to 10 years from diagnosis. It does fluctuate, but there's an issue here of background mortality that I also want to talk about. And it's also very important to remember that this is the diagnosis rates, and what we discussed earlier, incidences were happening 2 or more decades earlier. Below this here, we see, I think it's important to have some context, is mortality rates. And so here is the latest available Irish population table, number 17. I'm sure given the audience today, you know all these figures off by heart, but I thought it'd be no harm to sort of quote them. And certainly when you see the figures for age 85 and 95, they are very, very striking. And so what this means, for instance, if a patient is diagnosed age 65, 70, yeah, they probably will live 8 to sort of 10 years. But if they're going to be diagnosed age 85, 90, 95, it's clearly going to be shorter. It also has the impact of distorting the ratio of female to male patients of the disease, because women naturally sort of live longer than men. And that, I think, sets out the context from a demographic perspective. Now, one striking thing as well from a demographic perspective, it has been observed in recent decades that the incidence and diagnosis of Alzheimer's disease is actually falling. Now, different studies show different figures. The one I went with in my own report suggests a rate of decline of about 13% per sort of decade. Now, the reasons for this are not fully clear. Clearly, it's actually welcome news. But I myself, making the decision to link this to another issue. Often when Alzheimer's disease is discussed of late, you will see frequent reference to risk factors. And this table here tabulates some of the best research on this area. And what this is showing is essentially the actual loading that people would have for being diagnosed with Alzheimer's based on certain background factors. So the top one there is substantive hearing loss, which gives you a 90% loading. And these are modifiable risk factors. So clearly it excludes issues like age and sort of genetics. Now, when we look at a lot of these risk factors, we do note that there have been substantive improvements in recent decades. Clearly, smoking rates have been in constant decline since the 1960s. There are much better medicines for dealing with high blood pressure and sort of diabetes. Hearing loss, there are good hearing aids. There is much better health and safety. If you ever see a building site and people wearing ear sort of protectors as an actual example. So there are clear-cut reasons if given these risk factors as to why incidence rates and diagnosis rates actually will be sort of falling. And so while what I'm saying here is certainly very plausible, I do have to acknowledge the link is not sort of categoric. Now, I also point out, this is the trend to date. Will this continue into the future? I would argue it actually will, because the key demographic ages for Alzheimer's are more likely people in their 80s and 90s. So even some issues where progress has been happening since 1960s or 70s or 80s, they actually still will have to play out for people who are currently aged in their 80s and sort of 90s. So I think there are several more decades of this decline to actually come if you accept this actual link. However, I think it's very important to note, given the background aging that's going on in many developed countries, that any reasonable projection of Alzheimer's disease still shows an absolute rise in the number of sort of cases in the coming years. And then sort of moving on here. So firstly, we come up to the currently available drugs for Alzheimer's disease. As noted earlier, they purely deal with sort of symptoms. So going back into history, when the modern understanding of Alzheimer's disease actually arose, scientists wanted to get a concept of what they should be trying to sort of focus on. And the first idea, what was known to explain Alzheimer's disease, was called the cholinergic hypothesis. One of the tough things about this presentation is there are a lot of sort of tongue twisters here coming up, so please forgive my pronunciation. And here we have the first one here is acetylcholine, which I'm just going to refer to as sort of acet from now on. So this is a neurotransmitter that's pivotal to the formation of sort of memory. And what happens, of course, in Alzheimer's disease is acet actually is formed inside the neurons, but Alzheimer's disease progressively destroys those sort of neurons, which means there is less acet circulating in the actual brain, and hence the formation and recall of memory is severely sort of disrupted. And hence you have one of the telltale signs of Alzheimer's disease. That's how it actually arises. So scientists said, hold on a minute. If we could treat this acet deficiency, maybe we could halt the progression of Alzheimer's disease. Now that immediately ran into some major problems. I will discuss it later, but it's actually impossible just to give the patient, if you like, a supplemental form of acet that would then boost the levels inside the brain. That just can't happen, and I'll explain that sort of later on. But then some Japanese scientists found a very clever way around this problem. There's another chemical inside the brain, and its function is actually to control the level of acet so it just doesn't get too high, because that can lead to other sort of problems. And they felt if you could block this other chemical, then in a sense, you could take the actual brakes off acet inside the brain, and its actual level could resettle down to a new higher sort of plateau, and that higher plateau would allow for better sort of memory sort of functioning. This research led to a drug that is commonly known today as Aricept, and this was demonstrated in trials to improve patients' memory for a period of, say, 5 to 18 months. But after that, the loss of memory starts to build up again. And importantly, they have never been able to demonstrate that patients actually live longer if taking this drug. So the core problem is that the drug is not treating the disease itself. So the neurons just keep on dying. The levels of acet being produced keep on falling. And even if you've taken away the chemical that controls its actual maximum level, that won't do any good if there's virtually nothing being sort of produced, and hence the mental decline continues. This is a very successful drug, as you might imagine, and in today's money, maybe a little over 5 billion worth of sales. There are also some other hypotheses tried out early on, and again, another tongue twister here for me. So the glutamatergic hypothesis refers to another neurotransmitter called glutamate. Again, this was out of line in Alzheimer's disease. Again, they found a way to try and normalize it. Again, it helped patients on a temporary basis, but it was not treating the underlying problem, so the disease just keeps on progressing. Now, on top of all of this, this table here shows all the substantive Alzheimer's disease clinical trials from 2010 to 2023, with one exception. And all these trials, all 39 actually failed. The eagle-eyed among you watching this will realize there's actually one extra here at the bottom than is in the written paper. That's a trial that actually, when I submitted the paper to Society a couple of weeks ago, the results weren't available. The results came out last week, and sadly this trial failed as well, so I added it onto this table. Just to talk through this table briefly, it's a large table, but I wanted to get across the idea of just how many failures there actually have been in sort of recent years. So in terms of the hypothesis that these drugs are actually using, that's addressed in the second column. And you can see the actual dominant one here is referred to as the amyloid hypothesis. So this refers back to the amyloid plaques that I discussed earlier. And the concept here is that if you could remove these amyloid plaques from the brain, that people reckon this could be at the core of the actual disease. And if you could remove them, you could actually halt the disease in its actual tracks. The next column here is the medicine mechanism, and that's the biological process that they're actually taking advantage of to try and implement the hypothesis. And you can see for amyloid, a number of different techniques have actually been used. I think the other thing that's noteworthy here, if you look over to the last column, it shows the various Alzheimer's disease stages that they were trying the actual drug out. Back up in 2010, you can see the more advanced stages were being followed up mainly. Certainly moderate and sort of severe are there for the sort of first one. Moderate is there then in the following cases. But then as we come up to say 2015-16, there is a general trend starting up where they're looking at patients earlier on in the actual disease. So the phrase prodromal sort of starts up and becomes quite frequent. And then, as the one I've just mentioned, the most recent one there, in fact, it was investigating at the preclinical stage, and I'll talk about that one sort of later on. So the general idea of you have to go earlier into the actual disease, and that follows a pattern in many other illnesses, such as cancer and heart disease, where the best way to treat it is as early as sort of possible. And again, this slide just sort of talks through the actual points there. One additional point here, I'll just draw attention to that I mentioned in this slide here, is that two drugs here called aduhelm, and then another tongue twister for me, gantenerumab. They use a modified form of the amyloid hypothesis. They said, look, it's not the actual end stage plaques, it's the intermediate stage when the amyloid, the corrupted amyloid is actually soluble and is circulating around the brain. They felt that was the actual bigger problem. And so they represent an offshoot of that hypothesis, but certainly a very important offshoot. And I will be talking about that later on. So there was then a controversy over one of these failed drugs referred to as aduhelm, and you can see it back up here, about 2/3 of the way down. It had two trials reported in 2019 as an actual fail. Now, what happened in 2019, it's an important but complicated story, but I think it's worth going through, is that many drug trials have what's known as a futility test built in. So this is halfway through the trial. You will take a snapshot of the available data, and what you're hoping to see is that the patients on the active drug are doing better than the patients on placebo. Not necessarily proven out, but that there's a general trend of that happening. So the logic here is you don't want patients to be continuing to be given a drug that's not doing them any good, and also these trials cost an awful lot of money. So this futility test was performed in 2019, and sadly, it showed that actually aduhelm was not helping patients. That was the general conclusion. Now, the sponsors of the trial said they would look at the full data and they would come back and report that to the US Stock Exchange. But people didn't think too much of it at the time. Several months later, they did come back, and there was a shocking outcome. The company said actually one of the two trials at the higher dose of the drug aduhelm being used actually did end up statistically passing. So that was amazing news, but there was a number of severe problems. From a statistical point of view, when you carry out a futility test, as the title suggests, that's it. You don't get an actual sort of second go. So any data that they were producing was in reality post hoc. Importantly, the second trial did not show that patients in aduhelm were actually doing better. In fact, it showed that they were doing marginally worse. Also, it showed that more than 50% of the patients on the higher dose had a serious side effect referred to as ARIA, and I'll talk about that sort of later on. So there was very mixed views on this situation, but what ended up happening was the US regulator, the FDA, ended up approving aduhelm to treat Alzheimer's disease in 2021. That itself was controversial. the regulator called together a panel of experts to pour through the actual data, and that panel of experts clearly decided it should not be approved. The FDA still decided to actually approve in the end, despite that. Aduhelm has been sadly one of the biggest commercial flops in the whole pharmaceutical industry, I would say, of the last 20 years. The launch was disastrous. The drug was withdrawn in 2022. The reasons why it was such a disastrous launch, two, I would say, firstly, stakeholders, I mean, treating doctors, insurers, industry experts, university professors, they were all very skeptical whether Aduhelm sort of worked or not. There was that one trial in particular did not show a positive result, and there was the statistical issues. They're also very wary of this area side effect, in particular if there was doubts as to whether the drug was actually working or not. Companies made a major mistake. The pharmaceutical companies involved, they priced it at a cost of $56,000 a year. And given the number of Alzheimer's patients in the US, that was going to be a tremendous amount of money. So what ended up happening was a lot of the insurers, US insurers who are key for paying for these types of drugs, they refused to actually cover it. And then strikingly, Medicare, which is a US federal system for people over age 65, which of course is pivotal for Alzheimer's disease patients, they very strikingly said they were not going to cover it either. And both these issues meant it just did not sell. I think it's also very, very telling that no other regulator around the world actually approved Aduhelm to treat Alzheimer's disease. So while technically you could say Aduhelm is the first drug demonstrated to treat Alzheimer's disease, I think if you look at the totality of the evidence, that's not really true. Now, given all these problems and failures, I think it's worth maybe stepping back a second and trying to put it into context why these problems sort of might be happening. So I thought it would be useful to compare some of the facets of Alzheimer's disease to COVID-19. As we alluded to earlier, I presented on this topic to the society, and I was always bullish that there was going to be vaccines and antivirals found. And in fact, it was from actually thinking through some of these issues where my bullishness sort of came from. So firstly, if you look at COVID-19 as regards the facet of disease understanding, so it was very quickly apparent that it was a coronavirus, this new novel SARS-CoV-2 coronavirus that was at the root cause of COVID-19. But alas, on Alzheimer's disease, it's simply not understood as of today why it even sort of starts. And that forces you down the path of all these various hypotheses. The second point is accessing the actual disease. It was quickly realized with COVID-19 that the immune system could readily access the coronavirus throughout the actual body. And therefore, it was very suitable for developing either vaccines or antivirals, which is what ended up happening. And critically, it's not, COVID-19 is not like the HIV virus, which is able to evade the actual sort of immune system. So it's not a given that a virus can be found and tackled by the body's immune system. So in Alzheimer's disease, there's this issue referred to earlier as the blood-brain barrier. It explains all the problems that the developers of the drug Aricept had. So what is the blood-brain barrier? It's a kind of shell of fatty cells that surrounds the actual brain. Its function is to inhibit what goes into the brain. In particular, it's looking to block bacteria, viruses, fungal bodies from getting into the brain and sort of harming it. But what it ends up doing as a side effect is a whole pile of medicines can't get through either. And that severely limits how you can treat any illness inside the actual brain. To give an example of how this can be a problem, the only other organ in the body that has a similar brain barrier are the human eyes. Human eyes are being an evolutionary outgrowth of the brain. So for instance, if you've ever had pain in your eye, or you've had an actual infection in your eye, you can't just swallow an actual tablet. You have to use eye drops. And the idea is the eye drop is then absorbed through the skin of the eye, and that's how you get medicine into the eye. There's no other practical way. So then we come on to the issue of animal models. Well, animal models are very, very useful when you're researching a new sort of disease. It allows you, if you find an animal that can also get it like human beings, as was the case with COVID-19, you can track how the animal contracts COVID-19, for instance. You can see how it spreads throughout the human body. And separately, if you develop a medicine or a vaccine, you can try it out on that animal and see does it actually help the animal or sort of not. When you come to Alzheimer's disease, a very basic issue is that only human beings get Alzheimer's disease. Some other creatures like dogs do get a form of dementia, but it's not Alzheimer's disease. So there is no viable animal model. There's also the issue of tissue samples, a bit like an animal model. So if you can extract a piece of tissue from a human patient, you again can see how the disease is actually progressing. You can again get an insight as to whether a vaccine is helping out that patient or not. Whereas in Alzheimer's disease, for obvious reasons, just extracting a portion of a patient's brain is just not practical. In terms of how quickly it takes to run a trial, in a pandemic, it is very quick to run an actual vaccine trial. So the Pfizer vaccine, which involved enrolling 45,000 patients, only took about sort of 4 months from start to finish. Whereas in Alzheimer's disease, you actually have to typically follow patients for about 18 months to work out whether their cognitive decline is actually sort of slowing down or not. And then last but not least, it's very easy to recruit patients for COVID-19 trials. Essentially put any healthy adult is a suitable sort of candidate. But for Alzheimer's disease, it's actually surprisingly difficult. Obviously, they have to have the disease. They have to be at the right stage for the context of the drug that you're actually researching. And again, you do have to be fairly healthy. You can't have a significant comorbidity, for instance, which sadly is the case with many elderly sort of patients. So it's actually quite difficult to find suitable sort of patients for Alzheimer's disease trials. And it's the totality of these issues that I believe is important in explaining why we've had so many problems developing drugs for Alzheimer's. Now, it's not all doom and gloom here. And, from now on, I'd like to think this paper becomes a bit more positive. So having some recent research advances. So going back again to 2010 onwards, when we looked at all those trial fails, the first issue was before 2012, diagnosis of Alzheimer's disease was purely done through questionnaires. And if enough boxes were actually ticked, the person examining you would probably come to the conclusion that you actually had Alzheimer's disease. Unfortunately, that process led to a lot of false positives. And it was, for instance, regarded in some of the clinical trials going on that perhaps up to a quarter of the patients that presumably had Alzheimer's disease were shown afterwards not, in fact, to have the disease, which clearly hugely complicates trying to prove a drug works against Alzheimer's disease or not. But from 2012, the diagnosis improved a lot, that new brain scans came along, and particularly if there was a PET scan done of the brain, you could identify whether the patient had these amyloid plaques or not. And then this, in conjunction with the traditional questionnaires, gave a much better handle as to whether the patient actually had Alzheimer's or actually not. From 2015, I would probably put it at, it's something I referred to earlier, the original amyloid hypothesis was discredited. There simply had been too many fails. But what that did critically was it opened up the pathway for new hypotheses to be tested out. So for instance, the amyloid soluble hypothesis being one, and I will talk about that sort of later on. From 2018, the US regulator, who is a very influential in setting sort of worldwide standards, lowered the clinical trial bar for success in Alzheimer's disease, particularly in the preclinical and prodromal stage. You had to demonstrate that patients had less difficulty handling the activities of daily life, but that rule never really made sense for those stages of the disease because patients can usually manage themselves. So the regulator agreed to get rid of those two, to get rid of that sort of rule, and that opened up a lot more trials to be held for the preclinical and prodromal sort of stages. And then one that's just happening right as we speak in the last couple of months, Roche, who's a major player in the medical testing and diagnosis market, they have launched a new blood-based diagnosis method. So what they're saying is if you give them a sample of your blood, they'll be able to tell you with a high degree of accuracy whether you have Alzheimer's disease or not. Now, these tests are brand new, and I think we need to spend some time looking at to see whether the real world results are equivalent to what the manufacturer has been sort of promoting. But certainly, Roche would be a very credible name in the diagnosis market, and it's very interesting to see them sort of do something like that. Now we come on to what I would regard is the first of these sort of breakthrough drugs. So this drug, thankfully, has a very simple name of Leqembi. And so in July 2022, it was reported that this drug passed its key trial in Alzheimer's disease. And what we have on the left here is a graphic sort of representation. The blue line shows the rate of cognitive decline for patients on Leqembi, and the other more beige color shows the patients who are on sort of placebo. So you can see that both arms are declining throughout the 18 months that they're being followed, but critically, the patients on Leqembi are declining at a slower rate. So their rate of decline is, in fact, as quoted there, is 27% less. And that's circled there on this graph. It's also circled at the 6-month point. That's where the people running the trial pointed out that the difference between those on Leqembi and placebo had become statistically sort of viable. Also, I think one of the immediate points from this is it does have to be acknowledged as a triumph for the modified amyloid soluble hypothesis. It highlights that this hypothesis does have something quite important to say about what, in fact, Alzheimer's disease actually is and how you go about sort of treating it. So, i.e., these soluble intermediate forms of amyloid look like they are a key component of the actual illness. There was a side effect called ARIA, which I referred to before. It was also an issue here. I will discuss that soon. And the next point is it's up for full approval in the US in July of this year, only a couple of months from now. Europe is a bit behind. I would expect approval either in Q4 of this year or Q1 of next year. And the sponsoring pharmaceutical companies have already set the US price point at being $26,500 per year in the US, clearly half that of Leqembi. As a rule of thumb, as a biotech investor, I would say drugs in Europe typically cost about 1/3 less than the US, but that's the precise amounts do have to be hammered out with national healthcare systems. I would say, by the way, as an actual aside, that as a biotech investor, I think this graph is, to me, a thing of beauty. Besides the statistical outcome, the shape is very good. What you see at the top left-hand corner is that the two arms are very, very close together. And then as time progresses, they gradually move apart. That is the classical pattern of successful drugs for countless illnesses, again, including cancer and heart disease. That as you take more and more of the drug over time, the benefit shows up sort of more and more. Whenever you look at a false positive trial, you will see a much more erratic progression, where you can see a big difference opening up almost in the first few weeks, and that might narrow again and then sort of widen out. This is a very consistent trend, and it's absolutely what you should be seeing in a drug that actually sort of works. Now, the next slide here is just highlighting maybe an editorial comment by me, perhaps partially. It's just saying that medicine development is actually very, very hard. So, for instance, we have just said that the Leqembi outcome does give credibility to the amyloid soluble hypothesis, but we had discussed before that two other drugs, Aduhelm and gantenerumab, if I pronounced that properly, also used the same hypothesis, but they didn't work. So what this table here shows is a more detailed breakdown of the various trials. So the key trial for Leqembi, or it's also referred to as a phase 3 trial, shown in the first row. You can see the nearly 1,800 patients enrolled. The issue that I mentioned in the previous slide, a 27% relative sort of benefit. The next column, very, very important, it's referred to as the p-value. So this is a statistical comparison between the patients on placebo and the patients on the active drug. And it's the statistical probability that the difference you see between those two different arms actually is purely down to chance or sort of good fortune. And the standard is that the probability of this chance or good fortune must be less than sort of 5%. And if it's lower than 5%, that satisfies sort of regulators that the drug must be doing some sort of good. And here the p-value for Leqembi was really, really low, 0.005%, incredibly sort of low. A lot to do with the amount, the 1,800 sort of enrolled patients. And to your right, you see this area percentage. So area, again, just to explain briefly, this refers to a common type of symptom seen in a lot of these type of medicines. It's a form of microstroke or a microcardiovascular event inside the actual brain. Now, critically, to put it into context, it seems to be happening because these drugs are trying to remove parts of amyloid from the brain in a you could argue at an unnatural rate. And what this is doing, it seems, is putting pressure on the brain, on its plumbing system or on its sort of piping. And when you put too much pressure on, occasionally, well, something can actually partially break, and you get these mini sort of strokes. Now, before anyone gets overly alarmed here, about 90% of cases of ARIA, the patient actually notices nothing. It's only that it shows up on an actual scan carried out as a part of the actual trial. So less than 1/10 will show any sort of symptom, and the majority will just feel a bit of confusion or tiredness or something like that, and it will pass within a few hours. A small minority, this 10%, it is more severe. They may end up in sort of hospital. A subset of those, again, may have to be brought into the ICU. And in 3 cases of patients who have taken Leqembi, there have been deaths, and there have been media reports linking the Leqembi ARIA side effect to their death, although these cases are just currently under sort of dispute. Leqembi did have an earlier trial run, referred to as a phase 2b trial, that was exploratory. Very heartening there. It showed a very similar benefit of 26%, and that's what you need to see for a drug that actually sort of works. You should be getting consistent sort of outcomes. The p-value is much higher, only because there's 400 patients actually been used in the trial. Briefly on Aduhelm, you can see the core problem is, yes, one trial did show a 22% benefit, very good. The other trial showed a -2% benefit, and that was the problem of that particular drug. And gantenerumab did show, to be fair, a consistent level of sort of benefit, but it was much more modest at 8% or 6% over a period of 18 months. And as a result, it did not meet the p-value bar of 5%, and it was deemed to actually fail. So it's worth noting that Leqembi also has had the lowest rate of ARIA of those sort of 3 sort of drugs. And this highlights, I think, the brutal nature of sort of drug development. So even despite, if I go back up here briefly, look at all those fails. Then we come down to the 3 drugs that actually look like they actually chose the right path. Of those 3, 2 actually fail. More than likely, the total cost of running the trials up to the point that they failed for both of Aduhelm and gantenerumab, probably of the order of $500 million. That's a complete write-off. And Leqembi will actually probably get, you have to see what will happen, maybe between $5 to $10 billion a year in sort of peak sales. Radically different outcome. And that does explain the broad issue of why drugs cost so much. It's because you have all these fails going on, and rationally, for investors to put money into this industry, they have to see that the eventual people who sort of succeed will do well financially. And what you're ultimately seeing here is that microscopic improvements in the drug design of Leqembi versus the other 2 ones more than likely led to a profound difference in sort of efficacy, and also then a profound difference in the resulting commercial sort of rewards. Okay, sort of moving on. So then I wanted to kind of put some of the benefit of Leqembi into context. It's a bit difficult because the drug hasn't been fully launched yet, but I did come across a good paper that actually extrapolated data from the previously completed phase 2b trial, which is that second one there on the previous slide. And what that showed overall, that patients on that trial probably would live of the order of 1 year longer. And when they broke it down, what they said was patients in the prodromal and mild stages should benefit the actual most. But ironically, what it showed a complicated result, and this is why some models are interesting. They're often wrong, but they do show important sort of trends. And so what it says was that patients, after living longer in prodromal and the mild stages, would actually spend less time in the moderate and severe stages. And this is to do with the issue of background mortality. The longer you live in prodromal and mild, clearly you're getting older and older. So by the time you move on to the moderate and severe stages, you're several years older, and the chances of dying from background mortality are materially higher, particularly if you're into your 80s or sort of 90s. Now, I should stress that this exercise was done on the basis of a population mortality, and certainly any actuaries working on specific insurance or pension portfolios, there's usually a very common theme there, that the socioeconomic profile is higher than the population average. On that basis, background mortality should be lower. So I would argue perhaps in those portfolios, you took out the issue of background mortality. Patients on Leqembi live 3 years, so therefore in a socioeconomically advantaged group, the answer would be somewhere between 1 and sort of 3 years. Now, a key point I like to discuss, because clearly there's many clever actuaries who can work out very intricate models of what a drug might do to mortality. I thought I should spend some time talking about take-up, because it's not commonly understood outside the industry. People would think if there's a brilliant new drug, everyone takes it. Sadly, that's not what actually happens. So the issues that would be relevant here, I would think this is quite an expensive drug. The area side effects, particularly if media reporting starts up in cases that lead to eventual death, as to what that could do. The dosing is actually currently very complicated. You have to go to a medical facility. The drug is given through in intravenous drip every sort of 2 weeks. That is a very harsh way to deliver an actual drug. And also there's issues, well, not enough patients might be diagnosed early enough to take advantage of this drug. So my own reckoning overall was initially, as things stand today, I think assuming a take-up overall of 35 to 50% of patients in the prodromal and mild stage is realistic. Anything higher than that would not be in line with general thinking in the pharmaceutical industry. I also, however, do want to stress that that take-up is sensitive to socioeconomic status. There's a lot of evidence that people in higher socioeconomic statuses will show higher take-ups of new and novel sort of medicines, and will sort of use them sort of longer. I did make the observation again that you're not going to see any change to longevity overnight, that there is this issue that, again, something the people in the pharmaceutical industry would know, that new drugs do not sell well overnight. It is quite difficult to get the medical establishment to take on board an actual new drug. So it typically takes the order of 6 years before a new drug will hit what's referred to as its peak sort of long-term sales. And also you're dealing with the fact that current Alzheimer's patients do live on average between 8 to sort of 10 years, certainly if they're sort of somewhat younger. So when you look at that in some detail, you begin to realize any longevity gains, even if the drug is launched at the end of this year, will only show up in the 2030s. Also, what this paper produced was a very interesting part to me, given as Damien has mentioned, that I have a background on healthcare. Their model implied that actually patients on this drug would end up utilizing institutional care during the course of their life by a lower rate, and they estimated that to be about 30% lower. So what it's really saying is, if you're surviving longer with Alzheimer's disease, what's going to happen in reality, you're going to die from sort of something else. And something else is typically going to be things like cancer and heart disease. And those illnesses do not involve long-term periods of institutional care. Whereas when it comes to dementia, it's again a very stark figure, but something of the order of 50 to 70% of patients in institutional care have some form of dementia, and Alzheimer's disease is the dominant form of that. So I do also make the observation that institutional care usage is also correlated with socioeconomic status. So those figures could be higher than the 30% reduction and 50 to 70% stats actually imply. And to me, while we obviously need to see some real world experience, the long-term impact of Leqembi could actually be more important for institutional care system capacity than it is for longevity. And given the issues we face with an aging population, that could be a very, very important sort of finding. Also on Leqembi, while we have this clearly one good trial, as is typically the case, there are other trials being run to actually tease out the full benefit of the actual drug. So the first one to mention there is self-injection. So self-injection is something that typically happens, say, in many diabetes-related drugs. And that's a lot more practical than intravenous dosing in a medical facility. Patients or their caregivers should be able to handle that in the patient's own sort of home. Also investigating is less frequent dosing than, say, 2 weeks. Clearly that should lead to a lower level of cost, but also importantly, there's a general rule of thumb, is the less of the drug you take, the less sort of side effects you actually sort of get, thinking of area. There's also a longitudinal study underway, and if I just scroll up briefly here, if you don't mind, you see this graph again here, and I'll discuss the issue of a widening gap between the two arms. Clearly the trial only ran to 18 months, so that's all we have data for, but a longitudinal study will highlight whether that gap continues to actually widen. And so the ultimate benefit could be bigger than 27%. And one of the sponsoring pharmaceutical companies in the most recent quarterly call did drop a hint that they think that might be on the cards. So just that's certainly one to actually follow. And then also there's the trials underway at the preclinical stage, and I'll be mentioning this shortly. The hope there again is the general concept that the earlier you treat an illness, the more benefit you actually sort of get. Now, despite all this being sort of very, very, very good news, I think several notes of caution are very much sort of warranted here. First point here, while a 27% benefit is great, it's certainly not 100%. And as a result, you don't think you can credibly argue that the amyloid soluble hypothesis is the full root cause explanation for Alzheimer's disease. It's certainly a useful point, and it's finally that we have a sort of foothold, but it's not the full root cause. And what that root cause is, we don't know. We also, for instance, don't know why amyloid gets sort of corrupted. So this drug deals with the situation after it starts to get corrupted, but why is it getting corrupted? As mentioned earlier, we don't know if using this drug earlier at the preclinical stage will be helpful or not. In theory, it should be, but theory and practice in biotech, trust me, are two sort of very, very sort of different sort of things. We can't get away from the fact that the ARIA side effect is a significant drawback. Again, media reporting could very much color people's perception of this drug. We'll have to see what actually happens. There's also the basic fact that about 1/5 of Alzheimer's disease patients also have a secondary form of dementia. Something like a Parkinson's, for instance, can happen. And even so, if you treat the Alzheimer's part, they could still be in a lot of difficulty from the secondary form of dementia. So we also, and last but not least, whatever all the focus here has been on amyloid, we do know that there's this second brain protein getting corrupted called tau, which there's evidence that it too is a troublemaker, but we don't understand at all whether a drug might actually, that if it treats these tau tangles, could also benefit other patients. This slide then, as alluded to earlier, it shows the current trials underway, not as many, but at the previous day, but again, it's only what's underway as of sort of today. Now, I draw your attention to some key points here. The first one is donanemab. Again, I may not have pronounced that properly. They do know this, I looked at it myself, it's quite a similar design to Leqembi. It has had some earlier trials done like Leqembi. Those trials were promising. I would say success here is plausible. Again, with biotech, you have to be very cautious until the outcome actually happens. To me, the probability is maybe 60, 70%, and it's due to report out later on this year. Whether it's better than Leqembi or worse, we'll just have to sort of see. There's generally a new hypothesis coming out as well that's been tested more and more. You can see in this table, this the idea of inflammation. Doctors are more realizing that in Alzheimer's disease, patients' disease are constantly being inflamed, and inflammation is helpful to the body in many cases, but only as a short-term process. Chronic long-term inflammation is usually never good. So they're trying to test out, is this linked to how Alzheimer's disease happens? Very curious to see what actually happens there. And the two, I've referred to this issue before several times, this testing out in the preclinical stage. So you can see the last two on this table, Leqembi and donanemab, both have trials running at the preclinical stage, and this will test out the big concept of whether earlier treatment is actually beneficial or not. Then moving gears on a lot, I did say there was two new medicines that were important. So the first one then is the issue of, refers to a specific cluster of symptoms that are observed with Alzheimer's disease. I list out some of the main categories of these symptoms. So agitation itself, irritability, wandering. This is like being found wandering around the actual sort of streets. It's repetitive behavior, like constantly opening and closing an actual fridge door. And then sadly, it can more escalate up to issues involving aggression and even psychosis. The prevalence of these side effects, different studies show different answers. One that I saw implied that 1/3 of Alzheimer's disease patients being cared for in the community show signs of agitation, but in institutional care, this rises up to 4/5. And I have to say, it is extremely challenging and draining for caregivers to deal with these symptoms. It's also demeaning, I think, to the integrity of the actual patient to be seen to have these behaviors, which are certainly not how they've lived the rest of their sort of life. So all in all, a very, very difficult part of this very, very difficult disease. Now, in terms of treating this agitation, there are drugs that are used and referred to as off-label, i.e. you're using the drug in a context that it wasn't actually approved for originally. And so a lot of very potent antipsychotic drugs are used to treat this agitation. Now, to be fair, if the patient is showing symptoms of psychosis, the drug is probably very, very appropriate. But it does give apparently some benefits that some of these behaviors go away. But when you analyze what's going on, a lot of the time it appears these drugs are working by the issue of sedation. And in more common parlance, the patient is actually out of it. And of course, you're not really treating the symptom, you are more smothering the actual symptom. And one of the very sad things about Alzheimer's disease is how much it erodes the patient's quality of life. And if you're going to be sedated on an ongoing basis on top of that, well, there's virtually no quality of life sort of left. Also, very worryingly, these drugs have been clearly demonstrated to appreciably elevate the stroke risk and mortality with Alzheimer's disease patients. There's even some evidence that actually accelerates the actual cognitive decline in sort of patients. So as of today, no other medicines have been approved specifically to treat agitation. I would say that the development process should be simpler than for Alzheimer's disease itself, in that the root causes of issues like agitation, irritability, repetitive behavior, the brain circuitry that causes that is better understood, which is a huge help. And the trials are quicker and cheaper, particularly any patient showing these symptoms, whether severe or mild, they are eligible to take part in sort of trials. And in recent years, there has been a build-up, if you like, of near misses in this area of agitation. And in the paper, I do give a more detailed account of those sort of near misses. Again, there has been a breakthrough here. And ironically, in the same month of July 2022, a brilliant month for Alzheimer's disease research, a drug called Rexulti did clearly show benefit to patients suffering from agitation. Now, this drug had actually failed in some previous trials for agitation, but very importantly, in biotech development, lessons were actually learned. Essentially, they used a higher actual dose and had a better trial design. And on their third go, they got a very clear positive result. The p-value here is just 0.26%, again, well below the regulatory minimum of 5%. This drug, Rexulti, is already approved for treating schizophrenia, but very importantly, they know from treatment there that this drug does not have the side effect of sedation. So whatever this drug is doing, it is treating the underlying biology of what's causing agitation in these patients, and it's not just trying to sort of smother it. There was no sign in the trials either of elevated stroke or mortality risk, which is very, very heartening. US approval is due here in May of this year. The European timeline is not clear as of the moment, but I'm certain it probably will be in the first half of sort of next year. Now, the list of ongoing trials here is short versus, say, Alzheimer's, but to me, it's actually promising. So if I look at the third one there, Masupurdine, its medicine mechanism is the same as Rexulti, so you'd be hopeful that will actually work. And both Auvelity and AVP786 have had promising data in the earlier trials, but clearly they need to replicate that data in their sort of pivotal trials. But all three, to me, have above average chances of sort of success in the next few years. Now I'm coming on to my last slide here, and I'm just about here at the hour mark. So the question I've often been asked over the years, people are aware that of my interest in biotech shares and researching illnesses, and often conversation comes on to Alzheimer's disease. And the question I've most commonly been asked over the years is, look, Ivor, do you think they're ever going to find a drug that's just going to cure Alzheimer's disease? Now, if you asked me about 10 to 12 years ago, I actually would have said maybe, possibly, was my initial view. But the more I've looked into and researched Alzheimer's disease, I think that's very demanding. I mean, if I look here at some of the requirements that you would have to have in sort of reality for if you want to use the word cure, I think what you're talking about is 100% reduction in cognitive decline, not 27%. that even the best medicines for people taking, particularly if they're elderly, are if it's actually a simple pill, even if it's self-injection, that's actually quite demanding. And obviously to have no serious side effects. So ARIA is clearly a significant sort of complication. And even aside from the drug, you would want more than likely to have 100% of patients diagnosed by the mild stage, and preferably a figure not too far off that by the early or prodromal stage. Waiting for the moderate stage is too much damage is actually being done to the actual brain. Also, you would not want it to take 6 years for the medical industry to start using this sort of drug properly. And that again goes through pattern after pattern after pattern. And it's supposed to take of 35 to sort of 50% for it to be properly useful and to be truly deserve the title of cure. You'd want to have a full take-up. Again, that has never been seen properly in the pharmaceutical industry. So I would argue the totality of this paper and this presentation, to me, makes this a highly unbelievable scenario. And to the extent in the paper, I think I used the phrase science fiction. I know that's strong language, but I would stand over those sort of comments. Now, I don't want to be downbeat or negative here. My own opinion as I stand here today, over a decade later, after starting to look at Alzheimer's disease, that I would favor a scenario where there's gradual incremental gains. So already we have Leqembi, and we can see there's going to be longevity gains in the 2030s. But as what noted earlier, there are a lot more trials underway to ascertain the full value of Leqembi, and there are other drugs which show some promise for investigation. There's issues, as also I spoke about, that there's new blood-based tests for diagnosing Alzheimer's. So my view is a steady incremental grind over the next 30 to 40 years. And by the end of that 30 to 40 years, what will happen is a lot of patients will probably still get Alzheimer's. They will be treated for it. It will be a background issue, hopefully something like diabetes that can be well managed. And in the end, patients will not die from Alzheimer's. They will die from some other illness, and their quality of life will not be measurably reduced while they actually have Alzheimer's disease. That would be the scenario about 30 to 40 years from now. It won't be perfect. There will still be some patients who won't take their drugs properly, that the drugs aren't quite suitable, but it will be a radically improved position from where we are today on a cumulative basis. And I'd also make the observation that I know in a lot of life insurance and pensions practice, a key long-term assumption looking at longevity is what's the long-term rate of longevity gains. And there can be lots of debates as to what this number should be. And in recent years, perhaps some of the improvement trends have actually weakened, and should that therefore lead to a weakening of long-term assumptions? My own view, as someone who doesn't work in this day to day, but has clearly I like to think know something about Alzheimer's disease, is that from age, for mortality rates to say 75, age 75 and higher, over the next 30 to 40 years, I wouldn't be weakening any sort of long-term improvement assumption, would be one of my conclusions. And a final comment is, I started off this paper by discussing how the ancient Egyptians understood what was Alzheimer's disease about 50 centuries ago from today. But in that 50 centuries, we have found no way to sort of treat this illness. Only in the last half century have we properly recognized it for what it actually is. But where we stand today, we have made the first breakthroughs in sort of treating it. And I think there's a pathway forward over the next 30 or 40 years, as I've said, to lead to a comprehensive improvement here. And to me, what some people might think my scenario is too long-term and too slow. In the context of 50 centuries, I think this is very quick and very profound change. And I, for one, am certainly glad to be living in an era like this where such profound progress is actually happening. So that's the end of my presentation. I'll now pass you back to sort of Damien for the question and answer session.
Great. Thanks very much, Ivor, and your breadth of knowledge and the depth of your interest and passion in this topic particularly is clear for the presentation. I found it really, really interesting and enjoyable. As we said at the start, people can submit questions using either the Q&A functionality or the raise hands functionality. So we already have a few in, and welcome everyone to pop some more in there if anything is on your mind. Probably in the interest of time, Ivor, if we keep them quick and try and get through the questions, it's probably the best way to try and get through a number. Maybe as a quick starter, Ivor, just in the Irish context, what is the state of play with Leqembi? Like when might that become available in Ireland, and what process has to be followed for that to happen?
Yeah, I'll talk to that. Okay, first I said that I mentioned earlier that Leqembi would probably be approved by the EU regulators in Q4 of this year or in Q1 of sort of next year. Now there's then a gap of 2 months because that's done by a technical committee. Legally, the European Commission has to ratify their decision, and they normally take 2 months to sort of do that. Because only the European Commission, technically under sort of treaties, can actually approve a European-wide drug, but they take the advice of these technical experts. Now, then there is a big question mark as to when it will be approved or paid for by the Irish sort of healthcare system, which we might label as the HSE, for want of a better phrase, and that's an unknown. I would be a bit concerned there. The track record of the HSE of approving what is in reality going to be a reasonably expensive medicine that will have widespread application is not great. If I were to use the example of, say, cancer, so I think most people here would be familiar with the cancer drugs that were launched about 5 or 6 years ago that harness the immune system to sort of treat cancer. So they're certainly the most successful category. But there's another drug called Enhertu, which is in the process of revolutionizing breast cancer care. It's much better than the current standards of care. And those standards, to be fair, have actually improved a lot in recent decades. Now, that drug was first approved by the EU regulator in Q1 of 2021. As we stand today, the Irish HSE has not approved that for payment under the Irish system. Now, that's just one example, but that's a tremendously promising cancer drug where it's very, so now clearly, to be fair to the HSE, they have difficult decisions to make about budgets. There's obviously a haggling thing going on about price and cost, but the pattern does seem to be the HSE for big drugs that cost a lot, decisions don't get made quickly. I wouldn't be shocked, and unfortunately I've given a long answer here, but it is an important question. I wouldn't be shocked if it takes 1 to sort of 2 years for it to be approved generally under the HSE. Before that, clearly there could be private use of it, but it's a drug that may cost sort of 20,000 euros a year, for argument's sake, is not within everyone's sort of price range. And also, a side issue is that Ireland, we are short experts in a number of areas, but certainly in the area of neurologists, Ireland is deficient. And they're going to be very important in terms of administering this drug and also helping to diagnose more patients at an earlier stage. So lots of challenges there. And I think this could be a 5 to sort of 10-year battle for it to be properly used in this sort of country. Again, a long answer, but I think that's a very important sort of question.
Okay, thanks, Ivor. So moving on then, a long question from Deirdre Coyle, and I hope I'll do it justice, Deirdre. I think the question, Ivor, is that given the difficulties for GPs in diagnosing onset of Alzheimer's at an early stage, and the potential that if these new drugs or the new drug was given at that earlier stage, it may facilitate even greater benefits long term. Is there a role for genetic screening or for mass testing of some sort to identify a higher risk population and perhaps have a public health strategy around this?
I think the short answer is yes, it would. I think listening to the 2 pharmaceutical companies that are launching Leqembi, they have placed a lot of stress on this issue of these new blood-related tests, that they would, if they're as successful as the manufacturers claim, it could revolutionize the diagnosis of Alzheimer's disease. Essentially put, you'd be de-skilling the whole process, because a lot of these questionnaires that get asked to patients, often it's required to have a speciality in the actual area. So they're placing a lot of their hopes that these tests over the next 3 to 4 or 5 years will become widespread. So in a way that you might get a test to say whether you have diabetes or not, it could end up something sort of like that, hopefully. If that were the case, yeah, that would be tremendously sort of helpful. So I think, the concept there of a national screening, when I go back to some of these sort of risk factors for, say, someone who's lost a lot of their sort of hearing, for instance, yeah, I can imagine that being sort of set up. But typically the pattern is, going back to my argument, of it takes up to, say, 6 years to reach peak sales. A lot of about that 6 years is healthcare systems adapting themselves to use a new drug properly. And the adaptation here is going to be quite sort of demanding. So perhaps it's even more like a 5 to a sort of a 10-year journey. But yeah, I absolutely agree with the question. A national screening program on the basis of blood-based testing, to me, looks like a strategically long-term sort of viable path.
Okay, thank you, Ivor. Moving next to a question from Laura O'Philbin, as you'll remember, I introduced Laura at the start of the talk as the head of research with the Alzheimer's Society.
Yes, absolutely, yes.
So Laura's question is, in your opinion, has there been more international discussion and perhaps critical discussion around the cost of funding disease-modifying therapies for Alzheimer's when compared with other diseases?
It's starting. I think that debate is certainly more advanced in the US, and I discussed the issue of Leqembi, that the price point they had picked there of $56,000, to my mind, was just, look, I'm a defender of the pharmaceutical industry, but that price point was just sort of stupid. It was more a price point that is used for drugs that treat multiple sclerosis. That's a much rarer illness, and I don't think they had thought it through properly at all. And that did lead to a firestorm in the US. And the US is a market that is known to be tolerant of sort of high pricing. So that then, as I mentioned, led to Medicare, which they have ironically never done before for an approved drug. It's never happened before that they refuse to actually sort of cover an actual new drug approved by the FDA. So that, to me, is an insight. There is going to be some very tough debates about sort of cost. And, clearly, come back to my earlier question, there's going to be a big debate with the HSC as regards how much the Irish system will actually pay. I suppose I would look at it from a slightly different direction, is, well, what value will society get back from it? Now, one concern I do have is that a lot of the care for Alzheimer's disease is not paid for. It's family members. So if you like, a lot of the benefit does not show up in the country's GDP kind of balance sheet. You can see a specific cost saving. Now, I know some people do give up actual working, for instance, to care for an actual sort of loved one. But so there will be some benefits like that. So we might struggle a bit to kind of demonstrate benefits in pounds, shillings, and sort of pence. But I think if there's a grown adult debate about less institutional care being taken up, the mental health of the actual caregivers themselves. Also, one thing I would add in is the Irish healthcare system is having huge problems at the moment dealing with winter-related illnesses with COVID-19. One of the winter-related illnesses is there's always a spike in pneumonia, and a lot of that spike in pneumonia is actually caused by Alzheimer's disease patients. Now, if you were to take that off the table and actually reduce it, that's actually worth something. So I think it's more a debate about the benefits versus the actual cost. But I very much take on board the sentiment in the question, perhaps, of what happened in the US was completely wrong. The $56,000 price point was crazy. But I think, ironically, that's been quite helpful, because I think Leqembi has come in with a more realistic price point. I know it's still high, but it's half of what was been talked about before.
Okay, thank you. Next one is from an anonymous attendee. We don't have the name. To what extent does the research apply to other types of dementia other than Alzheimer's?
It's a very fair question. I think it will help. So there is another type of dementia called frontal temporal, or I think it's called FTD in short. I think the actor Bruce Willis was being diagnosed with that, if I'm correct. That, for instance, shows up the actual tau tangles that Alzheimer's has. It doesn't have the amyloid issue, for instance. So if you broke into properly into Alzheimer's and figured out the role of tau tangles, you'd immediately have a link. You'd have a sort of read across to that form of dementia. Also, generally speaking, if an area of drug development is shown to be successful. In other words, people need to see how successful will Leqembi be, how much will it actually sell. One of the subtle things you see in biotech, that it's a business like any other. People want to see comparators. So the more they can see that a drug like Alzheimer's does very well, it makes it easier for startup biotechs to raise venture capital for other forms of dementia, and they use this as an actual reference point as to what might be possible. And versus a theoretical model of how much they sort of might sell, well, how much, once you have a clear-cut parameter, you actually take that level of risk off the table. So I would argue myself, it's more that it lowers the general risk cost of investing in the area of dementia research. And over a 15 to sort of 20-year period, that could be very, very important. And you've seen that, by the way, in sort of cancer treatments over the past sort of 20 years.
Okay, thank you. So next one from Donald Casey, the classic asking for a friend question. With such a long preclinical phase, what can your average 50 to 55-year-old do to self-manage their risk of developing the disease?
Yeah, I mean, it's a fascinating topic. One is, is sort of self-awareness. So for instance, if you do get an amyloid scan of your brain, you can determine there and then whether you're in this phase or not. And I think that may become a bit more common, or these sort of blood tests will also sort of show that up. So first you have to have sort of self-knowledge that you're actually in this space. And I think people have kind of shied away from it, because a lot of the medical people thought, and I understand the thinking of, well, if there was no treatment to give people, why are you putting this huge burden on them or telling them that they're on this sort of runway when you can't even manage it? Whereas I think we're heading into a world now where that's going to be different. But to go back to Donald's question, I think it's some of the issues there about sort of risk factors. So to go back to the specific risk factor of loss of hearing, that if you have prolonged amounts of loss of hearing, part of your brain atrophies. And that's the precise part of the brain where also memory formation and memory recall happens. And so that part of the brain atrophies, clearly you're more in line to progress quicker with Alzheimer's disease. So I think it is, if you don't mind me going back up towards the start of the presentation, I think it is people thinking about that sort of table there and sort of managing it as best they can. I think most things there are people are certainly aware that should be managed, but even some more subtle ones like social isolation and physical inactivity, you wouldn't immediately think of. So society, I think, should become more aware of these issues, and at the individual level, absolutely. But so certainly, if anyone's hearing is going at the moment, I would advise you to get that sort of thing too. Okay,
one of the interesting parts of your paper, I found anyway, was just the methodology used for the research and the kind of cost benefit thinking behind how the industry decides where, the wider biotech industry decides where to place its investments. So maybe grouping two of the questions that I have here. Do you think, given the difficult history of proven drugs in this sector, that the potential longer-term commercial success of Leqembi will lead to more money coming into the Alzheimer's area, or will it actually crowd out money, given that maybe Leqembi is viewed as having first mover advantage? And a more specific one, maybe on the methodology then, given the nature of the disease, is there a challenge in capturing the consent of patients to take part in trials for Alzheimer's?
Yeah, I'll deal with the first question. I mean, I think perhaps two slightly distinct questions. No, I think the first question is clearly, to me, it's absolutely sort of more money. We'll go into now. It's based on the premise that Leqembi is a successful launch, and then not the shambles that happened to Aduhelm. But I think it's in a very different place on that sort of scale. So again, the actual sheer commercial success, it's been shown in sector after sector. Once one drug succeeds, the kind of the actual bar for entry into that disease area goes down. VC capital providers are much happier to invest in an area where they can see the actual pathway to clear commercial success. Also, I would say the 27% benefit reduction, while it's very welcome, it's not anywhere near 100%. If it was like near 100%, it would probably close off further research. So for instance, in the area of cystic fibrosis, there's been one company, Vertex, has launched a whole pile of series of very effective medicines. And they're so effective, they probably have slightly crowded out other sort of interests. Other companies have looked at it and says, we're not certain we can do that much better there. But I look at Leqembi and see it's very, very different. People are looking, well, if we can get to say 35 or sort of 40, we could sort of take over here. So I also, if we had a similar level of efficacy, but we had less area side effect, well, you could also do better as well. So there are lots of ways where the current drug is a big step forward, but in of itself, it is not a proper cure. It's the ideal pathway for a second or sort of third drug to be in there. So the issue of consent, I think there was a second question, like that's always been there. You know, I did allude to the fact that it's complicated to get patients to sort of join. My understanding is in Alzheimer's drug research is the patient themselves must consent, but their caregiver or nominated caregiver must also consent to them joining the actual trial. And generally speaking, in practice, the patient's caring physician would also want to be supportive as well for that to actually happen. So there's a lot of safeguards there. I also stress they're very particular about not letting patients in who have comorbidities, who have, say, heart-related issues, or certainly in the case of Leqembi, a stroke-related risk, because it could be exacerbated. So they're very careful to kind of screen out patients who have other sort of issues. So there have been no concerns or difficulties of inappropriate enrollment in Alzheimer's disease trials that I'm actually aware of. The real difficulty is the rules are so strict, and they're strict for a good reason, but they do actually slow down the actual trials. But that's clearly the right balance of risk versus sort of reward.
Okay, thanks, Ivor. Maybe just one last question. We have a few more. They're just very conscious of the time, and maybe a quick view. An interesting one was the curious story of Aduhelm that you told. Do you know why that drug was approved by the FDA in those strange circumstances, or was that story ever told?
Yeah, I mean, I didn't, on the written paper, I kind of did censor myself on a few topics, and that was one of them. It's funny when you actually write something down, how much more cautious you become, but we're now in a freewheeling question and answer session. But you know, my own personal view, I want to stress that, is there was a background building up that under the US regulatory system, the FDA is directly answerable to sort of Congress and the political system in the US. And the political system in the US has been saying very clearly in recent years that they wanted to see some progress in the area of Alzheimer's disease. The Americans do take a viewpoint, and I do admire them for it, that with enough persistence and enough money, all problems can be sort of solved. And they were saying the regulators need to become more commercially positive here on the area and just get something approved in very plain language. And I think, to me, I think that culture had drifted into the FDA as to what they wanted to do on this particular drug. Also, there is the organizational issues. In the FDA, it's organized by disease type. So there's a neurodegenerative section to the FDA, and the head of that, a guy called Billy Dunn, had a reputation for, going with what he saw as the actual data. And it was very clear that he was positive on this drug. Now, there was some controversy afterwards. You can see some media accounts of that. I do respect Mr. Dunn. I think, it's very heartening to see a regulator who's willing to go with what their own version of calculated risk actually is. And I think that had something to do in particular as to why it was approved when the panel of experts didn't want it to be approved. Ultimately, there was some discretion there by the regulator. So I think that's the background to it. Now, and you could also say, to be fair to everyone involved there, that if you go back up, sorry for going through these slides here, there you can see Leqembi. Like, if you look at the trial that everyone was focused on, Aduhelm with the 22% benefit, it's actually not too far away from the 27 to 26% benefit seen on Leqembi. And they're both going after the same concept. So you could argue with the Leqembi stuff which came out afterwards that it does look like that trial for Aduhelm may have been right, but at the time that wasn't known, and certainly with the first Aduhelm trial that was given a radically sort of different sort of answer. So I can see how that actually happened, but I think it was more bungled. The launch was terribly bungled. The price point, as I said before, I can't defend that. That was absolutely crazy. And I think the management of the company that were leading to launch Biogen, they're experts in the area of multiple sclerosis. I just don't think they had a feeling for what they needed to do to sell a drug in a space like Alzheimer's disease. They weren't skilled up enough to do it. Whereas the Leqembi drug is being controlled by a Japanese pharmaceutical company called Eisai, and they look a lot more streetwise, and they look a lot more savvy to me.
Great. Okay. Thanks, Ivor. Just conscious of time, I'm sure a lot of people on the call will have meetings at 2 o'clock. So we'll cut it there, although there are a number of more interesting questions. So just in conclusion, thanks everybody for joining and for participating in the meeting today, which I think was very interesting, as evidenced by the number of questions and comments that came in. Thanks to the Society of Actuaries team for supporting us with technology and with organising the event today. And particularly thanks, Ivor, once again for the paper and for the presentation today, which belies a huge level of expertise and passion for the subject. So thanks very much for giving us the benefit of that today. And with that, we'll close the webinar. Thank you, everybody.